In this lesson, we are going to review tree diagrams and area models. The first thing we'll do is just making a tree diagram. If you look at the problem, it says a bag contains 1 penny, 1 nickel, 1 dime, and 1 quarter. 2 coins are chosen at random with replacement, meaning they're going to put the coins back in and then redraw. Make a tree diagram. So what I would do for this to start is I would give myself all my options for my first pick. I could pick either a penny first, I could pick a nickel, I could pick a dime, or I could pick a quarter. So those are all my options on my first draw from a hat or a bag or whatever it is. That's what I could draw. Then I put that coin back in the bag and I draw a second time. So on my second draw I have 4 options again. I have a penny, a nickel, a dime, and a quarter. So for all of these I have the same 4 options. Penny, nickel, dime, quarter, penny, nickel, dime, quarter, penny, nickel, dime, quarter. So there's an example of a tree diagram with replacement, meaning I put the coin back in. When they ask to list the sample space, you're going to list every possible combination you could pull out of that bag when you draw 2 coins. So I would go through my tree diagram and just list my options. So for pennies, it was penny, 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 nickel, penny, dime, penny, quarter. Then for nickels, nickel, penny, nickel, 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 dime, nickel, quarter. For dimes, it was dime, penny, dime, nickel, dime, 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 quarter. And for quarters, it's quarter, penny, quarter, nickel, quarter, dime, quarter, quarter. So there's an example of my sample space. So those are all my possible options. You'll notice below it asks, calculate the probability that 2 nickels are drawn. So if I look up here at my sample space, which of these has just 2 nickels? 2 ends, there's only one of them, right? And if you count, there's 16 total here. So for C, where it says the probability of 2 nickels, I'm just going to write it here so you can see everything. I'm going to say that is 1 out of 16. Next, we have the probability of 2 of the same coin. I'm abbreviating here. So 2 of the same coin means I'd have a penny and a penny, a nickel and a nickel, a dime and a dime, and a quarter and a quarter. So you'll see that that's 4 out of 16, and if I reduce that, I'd get an answer of 1/4. It is important that you include this part in your answer too, because you're telling people what you're looking for. And then my last one asks for probability that at least 1 penny is drawn. So at least 1 penny means I have 1 p in there. So this one has 2 pennies, that's why the at least is in there. So these are all pennies right here. And then I look for anywhere else that has a p. You'll notice I'm going across this way. So of the 16 choices, I have 7 that have at least 1 penny. If it would have said exactly 1 penny, I wouldn't have included the PP, and it would have been 6 out of 16, or 3/8. The next one we're going to do then is sampling with no replacement for the same problem. The only difference is now there's 3 coins chosen. So with my first choice, when I'm doing 3 coins, I can choose a penny, a nickel, a dime, or a quarter. And then since I'm using no replacement, I'm not going to put, when I draw this penny, the penny doesn't go back in the bag. My only choices left are a nickel, a dime, and a quarter. Same thing here. The nickel doesn't go back, so I have a penny, a dime, and a quarter. Here I'd have a penny, a nickel, and a quarter. And here I'd have a penny, a nickel, and a dime. So that's my second draw. My third draw then, for my third coin, would be I have a penny and a nickel used, so all that's left is a dime and a quarter. I have a penny and a dime used, so all that's left is a nickel and a quarter. Penny and a quarter, all that's left is a nickel and a dime. So you can go through and fill all of those in, hopefully, and see what you would get for all of those. As I go through and do that quick, I'm not going to talk the whole time because that might get annoying. So you fill them out and you see if you get the same thing I do. And then when you list your sample space, you'll have to list all of these out. So, penny, nickel, dime, penny, nickel, quarter, penny, dime, nickel, penny, dime, quarter, penny, quarter, nickel, penny, quarter, dime. And there's just my penny, so I'll do the same thing for every single coin. So you'll notice here, instead of having 16 total like I did the last time, I end up with 20 total. Actually 24, how about? Apparently I can't count my rows and columns. 24 total. So now the first one says the probability that 2 nickels are chosen. So exactly 2 nickels, I would think that says, right? Or even just 2 nickels in general. Since I didn't do replacement, the probability of 2 nickels is 0. Once I take a nickel out, I don't put it back in, so I can't get that. Then we'll do the probability that a quarter is chosen. So when I go through and look at all the ones that have Q's in them, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 out of 24, or 3/4. And then the next one is the probability of a dime followed by a penny. So anywhere you see a dime and then a penny. So dime and then a penny. Nowhere in the first column. Dime and then a penny. Dime and a penny. That looks it, right? Dime and a penny, dime and a penny. You might wonder about that one, right? Or that one. When I come here, dime and a penny. So it looks like I might only have 4. When it says dime is chosen followed by a penny, that means the next coin chosen would be a penny. So the 2 that I starred, they weren't followed by a penny. There's a penny after the dime, but not followed by. So there's a little bit of trickiness in the wording there. So I'd say there's 4 out of 24, otherwise known as 1/6. So we have one more that we're going to make a tree diagram for. It says a coin is tossed 3 times to determine the number of heads and tails. When you think about replacement with a coin, I can't, once I get a heads, do I put the heads back to get a heads next time I flip a coin? Well, yeah, there's always replacement because a coin's always got a heads and a tails. So when I do my first toss, my choices are heads and tails. And then my second toss of the coin, I have the same 2 choices, heads or tails, heads or tails. And then my third and final toss, same 2 choices, heads and tails, heads and tails. So let's list our sample space here. I'd go heads, 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 tail, heads, tail, head, heads, tail, tail. Then my tails. Tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So I have 8 total options here when I toss 3 coins. Below it says the probability of 3 heads and the probability of at least 2 tails. So let's look first for the 3 heads. There's only one of them, right? So that's going to be 1 out of 8. And then the next one, it asks for the probability of at least 2 tails. So at least 2 means 2 or more. There's 2, there's 2, there's 2, there's 2. So I would say I have a 4 out of 8 chance, or 1/2. So that's kind of all we're going to talk about for tree diagrams and sample space today. The next thing we're going to do is going to involve some area formulas. So just as a quick review, we're going to write down the formulas for these things. Square or rectangle is length times width. Square, you might think of side squared, but length times width works. The formula for a triangle's area is 1/2 base times height. A circle is pi r squared. And a trapezoid is 1/2 of times the quantity b1 plus b2, so the two bases, times the height. So just to have those, you can remember what those are. We now have some formulas we're going to look at on the back of that next sheet. It says, if a ball were dropped into one of the following regions, what would be the probability that it would land on the shaded region? So I'm going to count the number of squares I have in each spot. For example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 here by 1, 2, 3, 4, 5, 6. This is a 9 by 6. So my outside area is 9 times 6, so 54. And they don't give us measurements here, so 54 units we would say squared. And then I look at the inside. So what's the chance of me hitting the inside? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my probability of hitting the shaded region would be 18 out of my total of 54. So my inside, we said, was 18. So when I reduce that probability, the probability of me hitting the shaded region is 1/3. So then if I look at letter B, with the triangle, I know that my formula for a triangle is area equals 1/2 base times height. So my base, I would say, is 1, 2, 3, 4, 5, 6, 7, 8, 9.5, maybe? Well, no, that's a full 10 going across. So 1/2, 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the area here would be 50. That's my outside, or the big triangle, we should say. Then the area of my small triangle is 1, 2, 3, 4, 5. So we'll do 1/2, 5. And then that's the base, and then the height, 1, 2, 3, 4, 5. So 5 times 5, so the area of that would be 12.5. So for my probability, I take the shaded area divided by the total area. And when I take 12.5 divided by 50, my probability is 1/4. There's an example of the triangle one. Now my trapezoid, to find my, it's in a square, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. So my square has an area of 64. And then the trapezoid would be, the area for that would be 1/2, and then I add the two bases. So my bases are 1, 2, 3, 4, plus 1, 2, 3, 4, 5, 6, times the height. So my height in this case would be 1, 2, 3, 4. So I'd have 10 times 4, which is 40, and half of that is 20. So my probability is the shaded over the whole, which makes this 5/16. Last few here. Here they actually give me the areas. This one is 1400. They give me the area of the shaded figure here. And then to find the area of my rectangle, I'd take the 75 times the 100. So I'd get 7,500. And they want to know the area in the shaded region I would call as the green here. So I'd take the 7,500 minus 1,400. And that gives me my area of the green to be 6,100. So the probability of me hitting the green is 6,100 divided by the total area, otherwise known as 61/75. Letter E, we'll do one with a circle. My rectangle area is 40, and my circle would be pi r squared. So pi times 2 squared. When I figure that out, I can either use, I get 4 pi, right? So I can take my area of the shaded area, 4 pi divided by 40, and I can write that a couple of ways. One, the probability could be written as pi over 10, or I can actually use the 3.14 as my decimal for pi and divide that by 10, and I get 0.3142. So either one would work for that. And the last one we're going to do is another triangle. The problem with this one is they didn't give me my triangle's height. And so I would have to figure this out. So for my square, I know that my square's area is 100, right? 10 times 10, it's meters squared. My triangle is 1/2 base times height. Well, my height would be right here. So if I draw this in, they have labeled this triangle so it's an equilateral triangle, which means all sides are the same. So that's a 2. So since all my sides are the same, I can say that since this divides it in half, this is a 1. And that's a right triangle, so I can do my Pythagorean theorem to find this height right here. So I'm going to say 1 squared plus 2 squared equals c squared. 1 plus 4 equals c squared. So I'm going to get this height right here to be the square root of 5. And when I do that, except I did that wrong, hold on. Timeout. Let's slow that down a bit. Start over. Let's label our sides, because obviously I did not do that very well. Here we go. Here's my A is 1. I'm looking for this. My C is always my hypotenuse. It's opposite my right angle. So there's where my 2 is. So I'd actually have 1 squared plus b squared equals c squared. So I have 1 plus b squared equals 4, which makes b squared 3, which makes b the square root of 3. b happens to be my height in this case. So to find the area of my triangle, I'd say 1/2 my base of 2 times my height of root 3. And when I plug that in, I'm going to get the area of that to be really just root 3. So the probability would be, I'll go up here, my shaded area, let's see, we're looking for the green, right? So this right here, that area is root 3. So I actually, to find my shaded area, have to take 100 minus root 3. So I'm going to find the decimal value for root 3, take 100 minus that, and I get the shaded area to be 98.27. So my probability would be 98.27 divided by 100, and when I simplify that I get 0.9827. So that's the probability that I would hit the shaded area. Hopefully that makes sense to you. If you have any questions, make sure you let me know tomorrow.